Hello everyone, we are going to see about big O notation and time complexity analysis. The big O notation and time complexity analysis are fundamental concepts in computer science and are crucial for understanding the efficiency of algorithms. Here's an overview of what is this type typically covers. Introduction to big O notation is a mathematical notation that describes the limiting behavior of a function when the argument approaches a particular value or infinity. In the content of algorithm, big O notation is used to analyze the time complexity and how the runtime of an algorithm scale with the size of the input. Understanding time complexity. The time complexity refers to the amount of time an algorithm takes to run as a function of the size of the input. It helps in understanding how efficient an algorithm is in terms of its runtime. Algorithms with lower time complexity are considered more efficient. Common time complexities. There are several common type complexities that algorithms can have, including big O of n. Constant time complexity. The runtime of the algorithm remains constant regardless of the size of the input. Big O of log n. Logarithmic time complexity. The runtime grows logarithmically with the size of the input. Big O of n. Linear time complexity. The runtime grows linearly with the size of the input. Big O of n log n. Linear arithmetic time complexity. The runtime grows in proportion to n multiplied to the logarithmic of n. Big O of n part square 2. Quadratic time complexity. The runtime grows quadratically with the size of the input. Big O of 2 power n. Exponential time complexity. The runtime grows exponentially with the size of the input. Best case, worst case, and average case analysis. The time complexity analysis consider the best case scenario minimum runtime, worst case scenario maximum runtime, and average case scenario expected runtime of an algorithm. Big O notation typically describe the worst case time complexity. Next, we are going to see about space complexity analysis. In addition to time complexity, algorithms also have space complexity, which refers to the amount of memory an algorithm uses as a function of the size of the input. Space complexity analysis is also expressed using big O notation, comparing algorithms. The time complexity analysis allows for comparing different algorithms to determine which one is more efficient for a given problem. It helps in selecting the most suitable algorithm based on the size of the input and efficiency requirement. Understanding big O notation and time complexity analysis is essential for designing efficient algorithm, optimizing code, and solving computational problem effectively. It provides a framework for reasoning about algorithm efficiency and performance. Here I am going to show you a simple Java code example demonstrating the time complexity of an algorithm using big O notation. Let's consider a scenario where we have array of integers and we want to find the maximum element in the array. Now I will show you how to write a code in Java. For this I am going to use an online Java compiler. First I am going to create a file of max element. First I am going to give a public class and max name of the class. Inside that I am going to give a public static and it is an integer and find max of int array int max equal to arr of 0, taking first element as a max and I am going to iterate into array. For that I am going to use for loop int I equal to 1, I less than arr dot length and increment function I plus plus, and I am going to check a condition with if arr of I is greater than max, then I am going to tell max equal to arr of I. After that I am going to return max value. Next I am going to give a main function public static. I am going to give a void main. Here I am going to use the string args int array equal to, I am going to give an array of string 5 comma 8 comma 2 comma 10 comma 3 comma 6, and I am going to call a max length equal max element equal to, I am going to call a function find max, and I am going to use system dot out dot println um, element in the array is if I run this, see I am getting 10. The 10 is the maximum element in this array. In this code, the find, I am going to explain the code. In this code, the find max method iterates through the element of an array once, comparing each element with the current max element found so far. The time complexity of the algorithm is O of n, where n is the size of the input array. This is because the time taken to execute the algorithm grows linearly with the size of the input array. The main method demonstrates how to use the find max method to find the maximum element in the array and prints the result. This code snippet illustrates a simple example of analyzing the time complexity using big O notation in Java. The space complexity of this code is the phase complexity of the provided code is O of 1, which is constant space complexity. Thank you.